Hey, what's up, class? Welcome back for another episode of Math 1 Distance Learning. So we've been working with inequalities. We started off with equations. We spent about 7 weeks on equations, and now we've transitioned to inequalities, greater than, less than, and so forth. And today we're going to be doing the lesson that I call Working with Inequalities Part 3. So we've already done a Part 1 where we started solving inequalities. We did a Part 2 where we interpreted word problems that were using inequalities. And now today in Part 3, we're going to be graphing inequalities. So today I'm going to give you some strategies that you probably have never heard before. This is something that I came up with. I've told you before, I've been teaching 25 years, and these are some strategies that seem to help students. So here we go. You should have the notes in front of you called Working with Inequalities Part 3. So let's get started. I'm going to flip over to my DocuCam. Okay, so working with inequalities, and our objective is to be able to solve multi-step, one variable inequalities. So we're still going to work on solving. There are going to be some real basic ones today. But our main focus is going to be on being able to graph the solutions on a number line. So we want to be able to graph solutions on a number line. Let's start off with just a little review. An inequality, remember, is a statement that two quantities or amounts are not equal. So when we say inequality, the left side and the right side are not equal. This means one amount is larger and one amount is smaller. So one side is larger than the other side. When we talk about solutions, this is also a review. When we talk about solutions of an inequality, we're talking about any value that makes the inequality true. And often there are many possible solutions. Raise that up just a little bit. So often there are many possible solutions. When we're solving inequalities, there's not just one correct answer. There can be many solutions. All right, so let's start off with a couple of word problems as a review here. So in this one, right here, this first example, the student enrollment. So we don't know what the student enrollment is. That's our unknown amount. That will be our variable. The student enrollment at the school dropped by 100 students. So keyword dropped by 100 students. And now it is at most 900 students. So based on our first two lessons, Part 1 and Part 2, we should know how to interpret this and turn it into a mathematical inequality. So our student enrollment is our unknown amount. It dropped by 100 students, and at most means less than or equal to 900. Now, when we go ahead and solve this, I'm going to add 100 to both sides, and I get x, so our unknown amount is less than or equal to 1,000. Now, if I'm going to translate this or write this, we would translate this. We would say the original starting amount, so the student enrollment, whatever that amount was, the original starting student enrollment was, right here, less than or equal to 1,000 students. It was less than or equal to 1,000 students. Another way to say it was the starting student enrollment was at most 1,000 students. Okay, so real simple. We translated, we interpreted, turned it into an algebraic statement, an inequality, and then we interpreted our answer. Okay, let's try the next one. My piggy bank savings was cut in half, but it was still at least $100. So we don't know how much was in the piggy bank. That's our unknown amount. That will be our variable. And it was cut in half. So if we're cutting something in half, that means we are dividing by 2. But it was still at least $100. So what we're saying is the lowest it possibly was 100, but it was probably more. Okay, so now how are we going to solve this? Well, we need to deal with this downstairs Danny. So we need to eliminate him. The way we do that, we should know how to do that. We're going to multiply both sides by that downstairs number. So I multiply by 2 upstairs. These get canceled out. Over here, 100 times 2. And so now our solution is any value that's greater than or equal to 200. So then when we write our solution, we want to say the original starting amount of savings, talking about savings, the original starting amount of savings was greater than or equal to $200. Or we could say the original starting amount of savings was at least $200. Okay. All right. So those are a couple examples of just solving multi-step one variable inequalities, right? There's only one variable, the variable x. Over here, we only have one variable. Okay, so now we're going to transition and we're going to talk about graphing these inequalities. You probably have some recollection from the past on how to graph these. So let's start off with talking about our graphing symbols. So our graphing symbols. So if we have a greater than, when we go to graph a greater than, we want to use an open circle. So we're going to use an open circle for greater thans. If we have a less than, we also want to use an open circle. But as soon as we put that little equal sign underneath either one of these, when we put the equal sign, then we want to now, we're going to use shaded circles. We're going to shade our circle. A shaded circle will look like that. Okay. So greater thans or less thans, no equal sign. We just use an open circle. So we're saying that it has to be greater or it has to be less. If it's open circle, then it cannot possibly be included in the solution. But if we say that there's an equal sign, see there's an equal sign there and an equal sign here, greater or equal to, less or equal to, then we're going to use a shaded circle, which tells us that it could include the number. Okay, so now when we graph these symbols, I want you to think of these symbols as kind of like a street sign. Okay, so you've probably been told not to do that, but I'm actually going to teach you a strategy where I think it's helpful to think of that as a street sign. Okay, so if your variable is on the left side of the expression, so here's an example. Our variable over here is on the left side, right? If I was to draw right down the middle here a line, this would be our left side and this would be our right side. So if your variable is on the left side, then I want you to read the inequality symbol like it's an actual street sign. So I want you to think of it as an actual street sign, okay? And I want you to think of that street sign as telling you which direction to go. It's like a direction arrow, okay? So right now, if I'm looking at that street sign, it looks like it's pointing to go to the right, okay? So we'll do a couple examples here, but if your variable, this is really important, if your variable's on the left side, and we read, like we're reading a book, we read from the left to the right, I want you to treat that like it's a street sign. It's telling you which direction to graph. Okay, so here's a couple examples and then we'll do some examples together. So if you look at this one right here, our variable is over here on the left side. So our direction arrow is pointing, it's pointing that way. It's saying go to the left. It's saying, hey, go left. And if you go look at our graph over here, there's no equal sign. So we have an open circle and then we're drawing the arrow to the left, right? Our arrow is pointing, that's like an arrowhead. Which way is it pointing? Okay, let's try another one here. So on this one, we do not have an equal sign, missing an equal sign. So we have an open circle. And then this is telling us, hey, go to the right. So we're going to go to -1, right? This is telling us start at -1 and then draw your arrow to the right. And this, if we were to read this, we want all numbers that are greater than -1. So everything over here on the right side, everything greater than -1. On this first one here, this is telling us we want all numbers less than 5. So we want everything on the left of 5. Less goes left, greater goes to the right. Okay, now let's look at another one here. On this one here, this is got an equal sign. So right away, let's go and notice that we're shaded in. We're shading in because we have the equal sign. We're going to start at 1/2, positive 1/2. And then what way does your street sign, your symbol tell you to go? It's saying, hey, go to the left, right? So we're going to start here and draw our arrow going left. Okay, and then one more example we'll look at, and then we'll do a couple together. On this one, this is telling us we've got the equal sign, so we're going to go shade it in, color in that circle, shade it in, and then we're starting at 0, and then this street sign, your symbol, is pointing to the right. It's saying, hey, go that way, okay? All right, so now let's try a couple on our own where we graph. So if I look at number 8 here, let me move this up for you. If I look at number 8, we're not solving anything. We already have, here's our solution. It's telling us all numbers less than 6. Okay, so we do not have an equal sign. So is this open or shaded? Correct, it's going to be an open because there is no equal sign. And then which way is the street sign telling you to point? It's telling you to go that way, right? It's pointing that way. So we're going to come down here and we're going to draw our graph. Okay, we don't have to put every number in. I just chose some numbers here. But the important thing is we want to start at 6, and you need to make sure that you show us where 0 is. And then we're starting at 6, it's an open circle, and we're going to draw our graph to the left. Now don't stop at 0, the graph really keeps going. Okay, I just happened to stop there, but we're not stopping at 0. That's an arrow. It says every number that's less than 6. So 2, 0, -2, -4, everything, negative infinity. Okay, all right, let's try another one. If I look at number 9 here, on number 9, if we interpret this, this is saying any value that's greater than or equal to -5. So we have the equal sign. So we're going to shade it in. We're going to start at -5, and then our arrow is telling us to go to the right. So I'm going to come down here. I'm going to draw this in. Here's 0. Make sure you show us where 0 is. And then I want -1, -2, -3, -4, -5. I want a shaded circle. And then I want you to go to the right because this arrow is saying go to the right. Now, really important. Before I go to the next page, on all of these, let's go back and see what I said. I said if the variable is on the left side, then you want to treat this like a street sign. If it's on the left side, treat it like it's a street sign. Now, sometimes you're going to have variables that are on the right side. So we've got to look and see how we're going to deal with that. Okay. So if your variable is on the left side, it looks like that right there, it's over here on the left side, then I call this a Roadrunner alert. Okay, now what the heck do I mean by a Roadrunner alert? You guys know who the Roadrunner is right here? Roadrunner. In fact, I'm going to show you just a quick little short example of this cartoon. It's amazing to me. Some students have never watched a Roadrunner cartoon. So let me show you a Roadrunner cartoon. His arch enemy is Wile E. Coyote. And the theme of the cartoon is they're out in the desert and the coyote is constantly chasing the Roadrunner and he's trying to catch the Roadrunner to eat him for dinner. And the coyote is really smart, but the Roadrunner is just a little bit smarter and he always outsmarts the coyote. So let me show you a little bit. I'm just going to show you about 30 seconds of a video. So let me switch back and 1 second here. And I'm going to share my screen. And I'm going to show you just a little bit of this video here. Okay. Hopefully we don't have to sit through a commercial. Okay, so you've got the idea of that cartoon. Now, what does that have to do with what we're doing? Okay, well, just hang with me for a second here. Okay, so in the cartoon, the Roadrunner is always outsmarting the Coyote. The Coyote is really smart, but everything he tries backfires, and a lot of it has to do with because the Roadrunner is just a little bit smarter. Okay, so now, what does this have to do with what we're talking about? Well, let me flip back over to my camera here. Now, remember I said that if the variable is on the left side of the inequality symbol, then I call this a Roadrunner alert. So if it's on the left side, I want you to think to yourself that the Roadrunner is trying to trick you. Okay, now what do I mean by trick you? So I want you to imagine, I'm not a very good artist, but I want you to imagine that the Roadrunner and the Coyote are out there in the desert, and the Roadrunner is a little bit ahead of the Coyote. And so the Roadrunner comes running down this path, and he sees this sign, and really the sign is facing that way, saying safety is over there, because you don't want to go off the cliff. But what does the Roadrunner do? The Roadrunner is going to flip the sign and trick the Coyote. So when the Coyote comes running along, the Roadrunner is now up here in the hills. And when the Coyote comes running along, sometimes he's not that bright. And he looks at the sign and it says safe. And so what does he do? He goes and he runs off and falls off the cliff, right? Because the Roadrunner tricked him by flipping the sign. Okay, so now let's go back to our notes. So I just said to you, I just explained to you, if this variable is over here, it's not supposed to be there. It's supposed to be over on oh shoot, I just goofed up. If the variable is on, I put the left side, I just realized just now that I wrote the wrong thing. If the variable is on the right side, sorry, I wasn't paying attention. I probably just confused everyone. If the variable is on the right side, sorry about that. If the variable is on the right side, this is the right side, okay? If it's on the right side, then I want you to think of the Roadrunner as trying to trick you, okay? So this is not where it's supposed to be. It's supposed to be over here on the left side. So I want you to, that should be a clue that, hey, the street sign is not correct. We need to change our street sign. And I've talked with you in the previous lesson that you won't see an answer like this on your multiple choice. So I've already talked with you about having to reverse these. So if you reverse and you put your variable over on this side and you put your 5 here, we have to flip the symbol. Okay, so I want you to think of this like, hey, wait a second, something's up. The Roadrunner's trying to trick me. So this arrow is saying to go that way, but that's not really what you're supposed to do. Okay, so what you've got to do is you've got to switch the variable to the left side, and you've got to flip your street sign back the other way. You have to switch your variable to the left side. So if it's here, we've got to reverse it, and we have to flip the street sign. Okay, so let's do some examples here. We're almost done. Okay, so I look at this and I go, whoa, wait a second. That variable is not where it's supposed to be. So I need to reverse it. I need to put it over here, and I have to change my street sign. The street sign is trying to trick me. The coyote is trying to trick us. Right now it says go that way, but it's a trick. We really need to flip the street sign. Okay, so when we go to graph it, it should look like this right here. So really it should be here, and our arrow should be going to the left. So we start at 7. We're going to shade it in because of the equal sign, and we're going to draw it to the left. All right, let's go and try number 12. So on number 12, once again, it's like coming up and we have to think, okay, well, which way am I supposed to go? Well, right now, the street sign is telling you go that way. But if you go that way, you're going to be tricked and you're going to fall off the cliff. So we need to move that. So I'm going to move it. I'm going to move it over to this side. I'm going to reverse my street sign. So now the street sign is telling me go to the right. And I'm going to start at -4. It's an open circle because we don't have an equal sign, open circle, and we're going to draw it to the right. Okay. All right, let's try a few more here. Number 13. All right, the variable is not where it's supposed to be. This is on the wrong side, so we need to change it. And when I change it, I need to recognize that, hey, my street sign is pointing the wrong way. It's a trick. So I need to flip this, and I need to flip my street sign. So my street sign is now going the direction it's supposed to go, and that's supposed to go to the left. So I'm going to go down to -3. I'm going to shade this in, and I'm going to draw my arrow to the left. Okay. All right, a couple more. Variable is not where it's supposed to be. It's on the wrong side. I need to flip it over here, which means my street sign is also wrong. So I'm going to change the variable over to the left side, and then I'm going to reverse my street sign. The street sign said go that way, but now I'm going to reverse it, and it's going to go that way. So I'm going to go to 5. I'm going to shade it in because it's an equal sign, and I'm going to draw my arrow to the left. Okay, last 2. All right. On number 15, my variable is over here, but I need to isolate the variable. So I'm going to divide by -4. And we've already talked that if this is a positive and I'm dividing by a negative, if this goes from positive to now negative, I have to change my street sign. So I'm going to reverse that street sign. Now, is the variable where it's supposed to be? Is this correct? And it is. Okay, that's on the left side. If it's on the left side, then that's what we want. We want it over here on the left side. Now I had to reverse the street sign because I divided, but now I have this where I want it. So when we go ahead and graph, I can go ahead and go to -5 right here. So open circle, and then I'm going to go to the right because my arrow is pointing to the right. Okay, last one, number 16. So right away, when I look, I see that the variable's over here. So we're going to see if it stays over here. Okay, so the first thing I've got to do is subtract 6. Subtract 6 from both sides. These cancel. 30 take away 6 is 24. And now I'm going to divide both sides by 3. I'm not dividing by a negative, so I don't have to flip anything. So 24 divided by 3 is 8. Okay, but now you've got to remember that this is on the wrong side. The road runner is trying to trick you. So we've got to move this over to where it's supposed to be, right? This is the key. If this is on the wrong side, then we know the road runner is trying to trick you. So you need to flip that. You need to flip your street sign. And this is telling us open circle starting at 8, going to the right. So here's my number line. Here's 0, 2, 4, 6, 8, open circle going to the right. Okay. All right. So we're going to keep working on that. But I've been teaching this for a long time. And this strategy of thinking of the roadrunner trying to trick you, it seems to really help my students. Now, you may be sitting there thinking, oh, this is kind of corny. Just go with it. Okay. If you already know how to do it, great. But if the variable is on the wrong side, then you've got to realize you're being tricked. So you've got to flip your variable and you've got to flip that street sign. Okay. All right. We'll keep working on that. You guys have a great rest of your day. Bye.